So in 7.3, we're going to be looking specifically at double angle formulas and product to sum formulas. Those are the two most important formulas I want you to focus on. The other ones are sort of secondary. In this case, a question might ask you something like the cosine of x equals negative 6 over 11 and tell you that x is in quadrant 2. Now, if I draw a picture of what this looks like, if x is in quadrant 2, then we're going to be drawing an angle or a radian measure in quadrant 2. So there's x. Okay. Now, obviously, x is going to have a reference angle or a reference number. It's going to make a triangle, however. And this triangle, because it's cosine, is going to be adjacent over hypotenuse. So that tells me my adjacent side is negative 6 and my hypotenuse is 11. This is because I went back 6, up some amount, and then my radius is always positive. Now, I can clearly use Pythagorean's theorem here to find the missing side. So I'm going to go ahead and say negative 6 squared plus b squared equals 11 squared. So 36 plus b squared equals 121. When I subtract 36 away from both sides, let's see, 121 minus 30 is what? Let's see, 91, and then minus 6 more I think is 85. Hope I did my math there right. That'd be embarrassing if it wasn't. And then I square root both sides and I get root 85, which, you know, honestly can probably be simplified, but for the time being, I'm not going to worry about it. You guys can go ahead and think about that if it can be simplified or not. So now I've got my triangle. Notice it's in quadrant 2. And I want to find the sine of 2 times x, which means I'm going to be doubling whatever this initial angle was. If I double an angle in quadrant 2, this angle was originally between 90 degrees and 180 degrees. So if I double it, I'm doubling the entire expression, or inequality. So I know that 2x must be somewhere between 180 degrees and 360 degrees. Now I know some of you are probably thinking right now, well, that's not very specific because that's anywhere in quadrants 3 or quadrants 4. So my angle could end up somewhere in quadrant 3, or it could end up somewhere in quadrant 4, depending on just how big it is. Okay. That being said, we're going to go ahead and look at the sine of 2x. We're going to use our double angle formula out of the textbook. So we've got 2 sine of x times the cosine of x. Okay. Well, now I know what sine of x and cosine of x are because I've got my triangle from before. So I know that sine of x is the opposite over the hypotenuse, so root 85 over 11. And I know cosine of x is the adjacent over the hypotenuse, negative 6 over 11. When I simplify this, let's see, 2 times 6 is going to give me negative 12 times the square root of 85, and 11 times 11 gives me 121. So the sine of 2x is negative 12 times root 85 over 121. And that's, of course, assuming that I can't simplify root 85. I might be able to. Since sine is negative, that tells me that we had to go down. Notice it does not tell me what quadrant I'm in, but I'm not necessarily so worried about that. I've got my answer here for what the sine of 2x is. In addition to the double angle formulas, we're also going to have to use the product to sum formulas. So if you turn a few pages in your textbook, make sure that you write down the product to sum formulas. Just a real quick reason on why they are the way they are. Notice that the sine of 2x equals 2 sine x cosine x. I could write this as the sine of x plus x because 2x literally is x plus x, and this gives me still sine x cosine x. Now, if I multiply both sides by a half, I have half of sine x plus x. And on this side, I just have sine x cosine x. Okay. Here, if I expand out sine x plus x into my addition formula, I'm going to be able to regroup my terms, which is why in the product to sum formulas, you end up with sine u cosine v equals 1/2 sine of u plus v plus sine of u minus v. And I believe in our homework we're going to be verifying these problems. Oh, haha, that's funny. You can see the permanent marker from my mess up before. Anyway, good luck, and we'll talk